Okay. Hey, welcome back. It just blew my mind looking at the working of this machine. Let me ask you something. Who invented washing machine? Yes, it's 𝗙𝗵𝗲𝗄𝗃 who invented washing machine, and he was a jack of all trades. When I feel thirsty, I will take some water and drink. When the washing machine goes into the rinse mode, it takes in water too. Do you think we both are controlled by something similar? Then why doesn't it do functions other than washing? Wait, what about your computer? It can do more than one function. Now it's time for you to understand the difference between microcontrollers and microprocessors. A microcontroller is limited for doing specific functions, whereas microprocessors can do multiple functions. So we can conclude that a microcontroller is present in your washing machine and microprocessors are present in your smartphone as well as in your computers. In today's session, we shall learn and understand about Arduino, which can be used to perform limited functions using microcontrollers. Most of you might have wondered, what are these blue and green boards that I always see whenever I break some toys? Do you really want to know about these? Well, come, let's take a closer look. This is Arduino Uno. There are many types of control boards available in our component library. In our projects, we are going to use the Arduino Uno, which is available in our Tinkercad. What are we really going to do with this software? Let's begin with something simple. We all have tried to light an LED with a battery source at some part of our life. Well, we could do the same here too, but in a different manner. Do you want to do it? Let's go. As the first step, let's search for an Arduino. For that, scroll down through the component library. There you go. Here is our Arduino Uno. Now using the mouse, let's drag and drop it to our workspace just like this. Can you see a lengthy component over here? This is a microcontroller. When we were talking about the washing machine, actually we were quite talking about this component. Here it acts as a mini computer that functions as the brain to the Arduino. So basically, Arduino is a development board with a microcontroller in it, so that it can be easily connected to a computer for giving instructions. Like us, at first we must teach the Arduino what to do. After that, the Arduino will keep it in its memory and do things that we taught. This process is termed as programming and is done with the help of our computer. A blue board and a lot of pins. Don't worry, once you understand everything about this board, you can design your own electrifying projects. First, let's understand the different pins in Arduino. An Arduino has analog pins and digital pins. As you can see, the digital pins are from D0 to D13. So in total, there are 14 digital pins. Also, the 6 pins labeled as A0, A1, A2, A3, A4 and A5 are the analog pins. So for lighting an LED, we need to understand certain things. We need a voltage difference so that electrons flows through it. That is current, and the LED glows. Oh my god, it's Mr. X. I think he has an alert with him. Do not plug in small LED directly to your supply at home. An LED works only in small DC, and the LED bulb used at your home has its own safety circuits in it. Thank you, Mr. X. So kids, don't try this at home. Let's come back to our topic. An LED has a positive leg and a negative leg to provide a path for electrons to flow through it. Some of you may have noticed in your home that in certain switches on your switch box, you can find numbers written on it saying 1 and 0. What does it really mean? From what you have noticed, we could say that when the switch is at 1, the lights turn on, and when the switch is at 0, the lights are off. A similar way can be given using the digital pins on our Arduino. Simply, in the digital world, This positive is termed as high or 1 and the negative is termed as low or 0. So, in Arduino, the digital pins can be either high or low, which means each digital pin can be made into either positive or negative by the microcontroller or external devices to do various tasks. But in the analog world, things are different. Unlike digital, the positive and negative will be continuously changing to different values from time to time. In Arduino, we use the analog pins to connect analog devices to our microcontroller. We will be learning more about this feature in the upcoming classes. The digital and analog pins of the Arduino are input-output pins. That is, each pin can be used to give an input to the controller or can be used to deliver an output from the controller to external devices. Okay, now let's take a look at how to power up the Arduino Uno. Every electronic component needs power to work, right? We have two methods to power up the Arduino. One is the barrel jack and the other is the USB port. Using the barrel jack, we can connect an external adapter up to 12 volts that can be used to power the Arduino board. Also, we can power up the Arduino using USB-B port using our computer via USB A to B data cable. This port is also used to connect the Arduino with the computer. To power up any external device that requires up to 5 volts can be connected to the power pins provided in the Arduino board. This one is the ground pin, and we have 3 ground pins available in the Arduino. Ground pin acts as a negative terminal of a battery or low in a digital system. Among the power pins, the V-in pin has the same function as the barrel jack. We can power up the Arduino using V-in and ground pin. Now simply, the 3.3 volt pin is used to power up devices that can handle a maximum of 3.3 volts. I hope you got an overview about Arduino Uno. Now let's simply turn an LED on using the power pins of the Arduino Uno without any kind of programming. Where do we find an LED? Search for an LED in the component library and let's place it in our workspace. There you go. Now we are going to give power to the LED to turn it on. Let's use the power pins to light up the LED. Which pins should I choose? Do you remember the maximum voltage the LED can be connected to without being destroyed? Yes, it's 3 volt, but we don't have a 3 volt pin available in our Arduino. So here I am going to use the 3.3 volt pin and the ground pin to power the LED. But here the voltage is 3.3. So we need a resistor to limit the current and prevent the LED from burning out. Select a resistor from the component library and place it in our workspace. Now change the wire color to red and make a connection from the 3.3 volt pin to one end of the resistor. Then from the other end of the resistor, connect it to the anode of the LED. Now make the wire color black and connect the ground pin to the cathode of the LED. Click on Start Simulation and yes, the LED is on. Here we designed a simple circuit to turn an LED on using Arduino. Can you believe it? Oh my god, you became a creator now. Nothing becomes a good creation until you have your logics correct. If the LED was connected directly to the 3.3 volt pin, it would have burned out. So the connection of an LED using power pins is just as similar to the connection of an LED using a battery. You can try the 5 volt pin to turn the LED on. Don't you want to know how we connect the LED to the digital pins of Arduino and turn it on? So first connect the cathode of the LED to any of the digital pins of Arduino. Click on Stop Simulation. Delete this negative connection. Then I am connecting the cathode terminal to the digital pin 2. Click on Start Simulation and the LED is off. Can you guess why this LED is off? It's because in order to get a desired output from the input-output pins of Arduino, we need to set out code for that. So click on Stop Simulation. Now let's do some programming. So to create an output from this circuit, let's do coding. What really is this coding? From childhood itself, we have seen experts sitting in front of computers and typing something on the keyboard. Don't you want to know what that is? For creating our very first code, click on Codes. By default, there are some codes in our coding space. We don't need it, so just drag them to the left to remove it. In code, you can see several blocks. There are different sections with different blocks in it, such as output, input, notation, control, math, and variables. Every block has its own functions. Now, what is our requirement? We have a positive supply connected to the anode of the LED. But in order to light it up, we need a negative or low to its cathode, right? We know our Arduino pins can be made to either input or output. So at first, we need to specify whether it should be an input or output via coding. Here, we have to output a low from the second pin of the Arduino. So from the output section, we have to select Set Pin to Block. Now drag the block and place it in the coding space. We need to set the digital pin high or low to turn the LED on. As we have used only digital pin 2 to connect the cathode terminal of the LED, so we require only one set pin 2 block. We have connected the cathode to pin 2. So click on this drop down arrow and then choose the pin 2. Here the pin 2 is set to high by default, but we know that we have to set the second pin to low. Now click on the drop down arrow over here and change it to low. That's it. We just created a code to make the second pin low. Now click on Codes to hide the coding space. Now if we click on Start Simulation, our code will be saved to the memory of our microcontroller, and then it will execute our code and make the second pin low. See, the LED glows. Okay, we just made the second pin negative or low and turned our LED on. But what if we want to make the pin high and turn on the LED? Let's do it. Click on Stop Simulation. Delete these wire connections and the resistor. Drag this LED and place it over here. Here also we have a ground pin. So connect the cathode of the LED to the ground pin using black wire. Now change the wire color to red, and now I am connecting anode of the LED to the pin 13. Click on Start Simulation and the LED is off. It was just working fine, right? Then why is it not working now? Oh, we just forgot to tell our controller that we have changed the pin number from 2 to 13. And also, we need a high from it. Click on Stop Simulation. To turn the LED on, let's change the code. So click on Codes. We are using pin 13. So change the pin 2 to pin 13. As we have connected anode of the LED to pin 13, let's set the pin 13 to high. Click again on Codes to hide the coding space. Click on Start Simulation. And see, now the LED glows. Now let's connect both terminals of the LED to the digital pins. Click on Stop Simulation and delete the wire connections of the LED. Connect the anode of the LED to pin 6 using red wire. Change the wire color to black and then connect the cathode of the LED to pin 7. Let's change the code as we have changed the pins again. Here we have used 2 digital pins, but only one set pin 2 block is present here. Let's drag and drop another set pin 2 block just below the first block. Here we are using pin 6 and pin 7. So let's change the pins to 6 and 7. Anode is connected to pin 6. So let's set pin 6 to high. And cathode is connected to pin 7. So let's set pin 7 to low. click again on Codes to hide the coding space. Click on Start Simulation and the LED turns on. Now without changing the codes, let's try to reverse the connections and see what happens. Click on Stop Simulation, delete the existing wire connections, change the wire color to black, and connect the cathode to pin 6. Change the wire color to red and connect anode to pin 7. Here in code, pin 6 is still at high and pin 7 is still at low. Click on Start Simulation and you can see that the LED is off. This is because pin 6, where we connected the cathode of the LED, is getting high, and pin 7, where we connected the anode of the LED, is getting low state. That is, the LED's positive is set to low and the negative is set to high, which turns off the LED. Now you know how to turn the LED back on, right? Hold on, not by reversing the pin connections, but by changing the code. Let's do it. At first, stop the simulation and set pin 6 to low and pin 7 to high. Now click on Start Simulation and see our LED is back on. Then click on Stop Simulation. That's it for today. Now, how about an activity? You can add more LEDs to this circuit and connect it to the Arduino, and by using appropriate coding to turn them on. These activities will help you to be more thorough about the topics, and you can design more circuits easily with me in the upcoming classes. There you go. Now you really know something about Arduino and coding. But what you have learned till now is only a drop from an ocean. There is a lot more to learn. Take a deep breath and I will meet you in the next session. Until then, bye.